Hello, I'm Dr. Harper. This video is a homework Excel tutorial in Linear Programming Operations Management Part D. Let's bring up the problem. Part D is an assignment problem, a bank assignment. A bank distributes checks to different sites to be processed within a large metro area. Each site has the capacity to process different amounts of checks per day. The checks that need to be processed each day are personal, payroll, draft, and government. The total demand is different for each type of check, and the cost to process each type of check varies with the site. These values are summarized in the table. What is the minimum cost that can be achieved and meet the requirements? In other words, satisfy the demand and not exceed the capacity. So let's take this, Control C, and let's bring up Excel and solve the problem. Come down a ways, and so okay. Open this up and loose this. We have some. Let's combine these cells. Let's merge these cells. Oops. I want to unmerge them. There we go. We'll bring this down. We don't need this. Bring this down. And then take these. Let's unmerge these things. We don't need these. There we go. And let's enlarge this to see if... let's format these things. There we go. And then come over here. And then format these and bring them down. Okay, now we have something we can work with. Okay, and let's take away the border. Okay, there we go. Okay, now then, we have this right here is going to be our unit costs. Let's box these in. Here's our demand. Let's box these in. Here's our capacity. And so with this kind of assignment problem over here, we can have the demand and capacity equals the sum of the total demand are going to be these right here. We can see they're 1400 equals the capacity. Whoops. Sum of these right here. And what's our total capacity here? 1500. Okay, so the difference here is going to be simply is our capacity minus our demand. We see it's going to be 100. We should be fine. Okay, so now let's take this right here, Control C, and let's just paste it down here with just the values, and let's delete these. And this is going to turn out to be our decision variable right here. Let's box this in, and let's shade this in. This is our decision variables. Now this total demand here, really, this is going to be what is being processed. Equals the sum. This is how the checks, the processing of the checks. Okay, and copy this down. And this processing equals the sum of the column equals the sum of the column. This is what is being processed at each site. Now this right here equals the sum product of the cost of each check, comma, times how many checks are being processed. So therefore, this will equal the total cost. So let's box this in, shade it. This is what we want to minimize by changing how much that we are processing. So this is a bank assignment problem. Well, we have enough capacity, so we should have 100 left over, but let's just solve it. Go to Data, Solver. This cell right here is going to be our objective function. We want to minimize that total cost by changing all of these cells, and there they are. Add constraints. Well, first of all, what is being processed must be greater than or equal to its demand. We can't processed less than demand, because that's the requirements. And then add what's being processed by the site must be less than or equal to the capacity of the site, because it can't produce more, it can't process more than what the capacity is. And say okay, and there it is. Non-negativity constraints. Let's change the nonlinear optimization to simplex. Linear optimization, say solve. And sure enough, it says solver found a solution. All constraints and optimality conditions are satisfied. Keep solver, say yes. 2783. There it is, 2783. And so that is the answer. So good, we're good to go. Question number 2. From concern about the site processing a large number of one type of check, a limit of 250 transactions per type of check for each site is being considered. What is the minimum increase in cost due to this added constraint? We're assuming it's an increase. It may or may not be, but let's see what it is. It shouldn't be less because it's going to be because we are at a minimum already. 2783 is the minimum. It's either going to be 2783, the increase is 0, or it's going to be more. Okay, so we have the limit of 250 in each of these cells. So here's our limit. And let's say it's 250, and there it is. Okay, so we're adding another constraint. So go to solver, and we just add a constraint, and that is every single one of these is less than or equal to 250. Say OK, solve, found a solution, all constraints are satisfied, say OK, 2798. Oh, cost increase. Okay, so right here, the limit of the cost, let's say here cost equals. So let's take this, Control C, come up here, and then paste it. Okay. Now the limit over here, let's say no limit. Let's say no limit. And then go to solver again, and right here where we had the limit, let's just delete that and solve it again. And sure enough, there's our 2783. Control C, and so let's say paste the values here, and down here the difference equals the limit minus the no limit, and the difference is 15. And sure enough, that's what we found here, 15. There's our 15. Okay, very good. Question number 3. After the transaction limit was implemented, well, the 250, for each type of check for each site, the demand for payroll checks was increased to 900 checks per day, which increased the total demand for all checks beyond the total capacity. Aha! What's the minimum cost of processing as many checks as possible with the available capacity? This is a very good problem. So essentially, let's take the payroll checks. The payroll checks right here, this demand jumps from 400 to 900. And there they are. Aha, okay. So notice here, our demand exceeds our capacity, and so this will not give us a solution. This right here is not going to be the solution, but the thing of it is, notice what's being asked. It says, what's the minimum cost of processing as many checks as possible with the available capacity? So here, we're not going to have a solution saying, okay, we're going to meet all of our demand, but how much of the demand can we meet to minimize our cost? That's a good problem. So the way we do this, right here, here's our demand. We're going to need more capacity. So we're going to add a column in here. Control plus is adding a column. And let's call this a dummy. A dummy capacity. Dummy capacity. And I'm sure you can call it any name you want. I'm sure you know a lot of dummies. Anyway, the point is the cost is going to be 0. Okay. And the capacity here is going to be 400. Okay, so now when I look at my capacity here, I'm going to say, well, now I have an extra capacity all the way to 400, and now it's going to be the same. So now I'm going to say, well, I have a dummy. Now this dummy doesn't exist, but I'm going to solve the problem, and whatever the dummy is going to be processing, that's not going to happen. But the rest of it will happen. So now I know what to do. Okay, first of all, I need to change the sums here. And this sum has to come all the way from here all the way to there. Whoops, I lost it. From here all the way to the dummy. I have to include the dummy. Okay, here I have to include the dummy. All the way to here. And include this all the way to the dummy. Dummy's in there. And this one I have to include the dummy. Okay, here I have to come all the way to here, comma, include the dummy, return, and there's our cost. And we're still going to have this limit here, but the limit, notice what is said here. Well, the limit, this limit here, it's not going to apply to the dummy because the dummy doesn't care. This limit is only going to apply to the actual sites. Because you can not process as many as you want. I can not process all of them, but I'm not going to satisfy my demand. Anyway, so now let's solve this thing. So let's come to data. Let's go to solver. There it is. Let's just reset all. Do it from the beginning to make sure we're right. Okay, here we have this right here. We're minimizing our cost by changing all of these cells, including the dummy. Adding constraints, the same as before, which processing is going to be greater than or equal to the demand. Add what's being processed at the sites must be less than or equal to its capacity. Well, they're going to be the same, so they're going to be equal. And then let's add the constraint of these sites have a constraint of less than or equal to the limit. Okay? So let's solve this thing. And there we have all solver-funded solution. All constraints and conditions are satisfied. Okay. 2680 is what we're going to have. Let's bring this over. 2680. And sure enough, whoops, do this again. Let's do it this way. Being obstinate. Oh, did it again. Hello. Come back. There we go. Bring this. There we go. 2680. 2680. We got it. Okay. Okay, well, that's all I have for part D for this problem. I hope this helps. Between now and the next time I see you, take care.